Have you ever wondered if the way we think about energy, time, and space might be missing something? I've been exploring an idea, not a definitive theory, but a perspective that reframes these concepts through the lens of wave dynamics. This isn't about making bold claims or romanticizing physics. It's about suggesting possibilities, asking questions, and inviting curiosity. Let's start with energy. It's often seen as either a discrete particle or a localized entity, but what if it's better understood as something distributed, like a wave? In quantum mechanics, energy already behaves in a probabilistic way, with crests and troughs representing potential states. Thinking of energy as inherently spread out over a wave feels like a natural extension of that idea. Now, if energy is a wave, what does that mean for time? In quantum mechanics, time is treated as a parameter, a fixed backdrop that lets us calculate how systems evolve. But I wonder if time could also be seen as the phase of these energy waves. Each point in time would correspond to a specific phase of the wave, directly linking temporal progression to the oscillatory nature of energy itself. It's a shift in perspective, and I think it's worth exploring. And what about space? If energy spreads out over a wave, then it makes sense to think of space as the medium through which these waves propagate. This aligns with relativity's view of space-time as the dynamic fabric where interactions occur. But maybe space isn't just a passive stage. It could be an active participant, shaping and being shaped by the energy waves moving through it. This brings me to Planck time. It's fascinating to think of Planck time as representing the smallest possible intervals within this wave framework. These intervals could act as coherence nodes, stable points where energy transitions from probabilistic behaviors to observable phenomena. If that's the case, Planck time might serve as a bridge between the quantum world and the continuous space-time of relativity. It's a possibility I find intriguing. Then there's the cosmological constant, lambda. It's often thought of as an imposed parameter, but what if it's something that emerges naturally? If energy waves influence the dynamics of space-time, lambda might simply reflect the average effect of those interactions. The oscillations of these waves could even explain things like dark energy or the uniform expansion of the universe. I'm not saying this is the answer, but it's an idea worth considering. The relational nature of energy is another part of this picture that I find compelling. If energy is fundamentally a wave, then it's less about isolated particles and more about distributed interactions. This aligns with quantum field theory, where particles are excitations of fields. And if energy behaves relationally, it's possible that reality itself emerges from the interplay of these waves. Coherence and interference patterns might give rise to structure, phenomena, and even the universe as we experience it. So, where does this leave us? I'm not here to say this is how things are, but to suggest that it's how they might be. What if time isn't just a parameter or operator, but a phase of a wave? What if space isn't just a medium, but an active participant in the dynamics of energy? And what if reality itself isn't static or intrinsic, but something emergent, shaped by the interplay of these distributed waves? These are the questions I've been thinking about. They don't have definitive answers, but I think they're worth asking. If this perspective resonates with you, or even challenges you, I'd love to hear your thoughts. Maybe together we can take this curiosity further and see where it leads.